This is a C1 video for Edexcel topic 3 chemistry for C1, which is all about acids. Let's go through this. It goes through indigestion, talks about neutralizing acids and how salts are created, and a bit about electrolysis as well. So our stomach contains hydrochloric acid, and there's reasons for that which you need to understand. It aids the process of digestion. You need to understand how it actually aids that process. There's enzymes in the stomach which digest food, and they work best in acidic conditions. So acidic conditions provide the best conditions for the enzymes to work in, or the optimum conditions for enzymes to work in. Hydrochloric acid also helps to kill bacteria, therefore you're less likely to get food poisoning. So sometimes you have an excess of stomach acid. That means you have too much. So to remove that, use indigestion tablets because they contain bases such as calcium carbonate, i.e. limestone, which neutralise the excess acid. So we've got a few questions that exam papers like to ask over us. The first thing is, what is the role of hydrochloric acid in the stomach? So you could say, aids the process of digestion, providing the optimum conditions for enzymes. Or you could say, hydrochloric acid helps to kill bacteria in the stomach, limiting the chances of food poisoning. They also like to ask what can sometimes cause pain in the stomach, or how is acids linked to pain in the stomach. You could say an excess of stomach acid is called indigestion, which could cause pain in the stomach. They could then say, how would you cure that? And you say, will you neutralise the excess acid using a base? So neutralisation of the excess acid. So some of these work better than others. You might, in the exam, be asked to describe an experiment for how you could test it. So you'd have an indigestion tablet and you dissolve it into water and an indicator. So you can see when it goes neutral. You then fill a burette full of hydrochloric acid. As the acid comes in, it will neutralise the indigestion tablet solution. The greater the amount of acid required, the better the indigestion tablet, because that means it's stronger. So the greater the volume of acid required to neutralise this, the more effective the tablet. So when we actually neutralise acids, what are we actually doing? Well, we're creating something called a salt. Any neutralization reaction involves an acid and a base. So there are three types of bases that you need to know about. There's metal oxides, hydroxides, and carbonates. With an acid to a metal oxide, you get salt and water. And an acid to a metal hydroxide, you also get salt and water. But if you have an acid to a metal carbonate, you get salt, water, and carbon dioxide. So there's three types of acids that these reactions could actually involve. So hydrochloric acid makes chlorides, sulfuric acid makes sulfates, and nitric acid makes nitrates. So if I had copper oxide and hydrochloric acid, I'd get copper chloride, because chloride is a salt from hydrochloric acids, and end up with water, because water is always made. However, if it was copper carbonate instead, and this time with nitric acid, copper carbonate plus nitric acid, I end up with copper nitrate, because nitric acid makes nitrate salts. Copper, because that's the metal. I end up with water still, and carbon dioxide, because that's the formula. It's a carbonate, so it's water and carbon dioxide. So acid plus base leads to salt and water. So here's some examples. So hydrochloric acid plus copper oxide, copper chloride plus water. Sulfuric acid plus sodium hydroxide is sodium sulfate plus water. Sulfate because it's sulfuric acid. Nitric acid or nitric acid plus calcium hydroxide is calcium sulfate plus water. None of those are carbonates, so don't have carbon dioxide used as well. So let's talk about electrolysis. Electrolysis is the breaking down of a substance using electricity. So it's decomposition. It's decomposition of a compound using electricity or electrical energy. It has to be DC. Okay, it does not work in any other type of electricity. It has to be DC. The liquid used to conduct electricity, we call that an electrolyte. So an electricity is applied using these two electrodes here. The electrolyte contains a compound which needs to be broken down. So in this situation, it's hydrochloric acid that we're going to break down. So this arrow over here for the hydrochloric acid, that should be pointing to the actual acid itself. A gas is quite often given off as part of this process. So hydrochloric acid can be broken down. So if you've got hydrochloric acid, it will break it down into the two things that make it up, which are hydrogen and chlorine. In the exam, don't quote it as the formula, quote the element. Write hydrogen and chlorine in terms of gases that will come off. Both these gases bubble through, so if you have a test tube, you collect it in the test tube at the top. Hydrogen will be collected on the negative side, while chlorine on the positive side. You can test to see whether hydrogen and chlorine are being produced. Okay, so we've done about the test for carbon dioxide in the previous video, in the video for topic 2, where they talked about the lime water test, lime water turning milky for carbon dioxide. Test for hydrogen is a squeaky pop. Okay, so it's a lit splint or lighted splint in a test tube of hydrogen. It makes a popping sound. You also need to know the test for chlorine. The test for chlorine is you take damp litmus paper, turns it white. First it will go red, but then it will go white. So damp blue litmus paper goes red and then white. Remember, chlorine is toxic. Okay, so wherever it's manufactured, it's hazardous. So if you breathe it in, it's dangerous for our lungs. But it has many uses. We use it to treat water supplies because it kills the bacteria. For manufacturing bleach again because it kills bacteria, and also for manufacturing PVC, polychloroethylene, which is a very useful plastic. Chlorine can also be extracted by the electrolysis of seawater or brine, because that's sodium chloride solution. So if you've got sodium chloride solution, you do get chlorine out of that as well. There is one more electrolysis that you need to know, and that is the electrolysis of water. Okay, so this is normal water, not seawater. Okay, seawater is sodium chloride solution, normal water is H2O. So the electrolysis of water is the same as the electrolysis of HCl or hydrochloric acid. However, this time oxygen is released along with hydrogen because of the fact that there's no chlorine in H2O in water. So the test for oxygen, to check that oxygen is being released, is you put a glowing splint into a test tube. So that's not a lit splint, but a glowing splint, and it should relight. Okay. So this time what you're going to get is, because we've got H2O, so you have H coming off, and you have O coming off. Okay, so there are two gases this time, when previously it was H and Cl. And that ends our video on topic 3 of C1 Edexcel Physics Acids.